Welcome to the session on cost optimization with containers and Spot. My name is Deepthi Chalupati. I'm the Senior Product Manager in the EC2 team focused on Spot instances. I have my colleague, Nick Holt. He's a Principal Product Manager for containers at Amazon Web Services. I've been with Amazon Web Services for the past 2.5 years, all the time focused on building features and services that can help customers take advantage of EC2 Spot instances. Just for my understanding, how many of you have already used ECS with Spot instances today? Just with a show of hands. Cool, few of them. So I think we have an exciting agenda and exciting updates that will definitely help you take advantage of containers with Spot instances after this session. So let's get right into it. First, I will walk you through what are the various containers and compute options that we have available on AWS when you are thinking to running your container apps on Amazon Web Services. I'm going to spend some 10 to 15 minutes here and then pass it on to Nick, who is going to talk about two things. One is how you should think about compute costs and performance, and two, what are the various tools and strategies that you can leverage in order to meet performance goals for your container apps at lower costs. So when you think of cost optimization, traditionally, it's always being thought of as a trade-off. So to meet your performance goals, you may have to over-provision your cluster, which means you're running more servers than needed, which means you're going above your budget. On the other hand, if you have to control for your costs, you may be running servers right the amount that you actually need, which means if your app's compute needs changes, you're trading off on performance. But what if I were to tell you that you can actually do both? Meet your performance goals at lower costs. So today, you're going to learn how to take advantage of EC2 Spot instances and Fargate Spot that we just launched at reInvent to run your container apps, which will allow you to meet your performance goals while lowering your costs both at the same time. So when you first decide to run your container apps on AWS, you start at the orchestration layer. That is required to run and manage your container control plane. So we have Amazon Elastic Container Service, ECS, and Amazon Elastic Kubernetes Service, EKS, both as orchestrators that you can use. ECS is a fully managed, highly scalable, highly available container control plane. It is designed to run across, integrate with different AWS services like Autoscaling, ELB, security, and IAM. It is designed for AWS best practices, and it is built to perform at scale. You can even take advantage of our CloudFormation or Terraform tools to manage your deployments. EKS is a managed Kubernetes service. It is also highly available with 3 master nodes running in 3 availability zones. It's running upstream Kubernetes, so you can connect with kubectl just like a self-managed Kubernetes. So both ECS and EKS make it simple to actually deploy, manage, and scale your container apps running on AWS. So once you have decided the orchestrator that you want to use to manage your containers, then you need to decide which compute option that you have to select to run your containers. So for compute, we have Amazon EC2. It's self-managed. You control what kind of instance types you want to use for running your containers, fully controlled by you. However, if you say, I don't want to manage the infrastructure on my own, then you don't have to worry about that. We have the second option, which is AWS Fargate, which is fully managed, serverless. So if you combine this with ECS, ECS manages your control plane, and Fargate manages your data plane. All you do is simply run your containers and pay for use. So just to summarize, when you are deciding to run your container apps on AWS, you pick your control plane, which is either ECS or EKS, and then pick your compute options to run your containers, which is EC2, self-managed, or serverless, which is Fargate. So when you come to EC2 compute option, we have 3 different purchase options. We do realize there are several different workloads out there, so we recommend you to take advantage of all the 3 purchase options for your needs. So to start with, the first one is on-demand. This is where most customers start. It's probably because you're running your net new application on EC2 and you don't know your workload requirements yet. So you simply turn on this EC2 instance, turn it off after a second, and we will charge you for that. So there is no long-term commitment. Second is savings plan and reserved instances. We just launched savings plans. So we have 2 options, which is compute savings plan, where you're saying, hey, I do like the elasticity with on-demand, but I don't really need it because I know I have an app that runs all the time and I need this steady state compute. So I'm willing to make a commitment for 1 or 3 years, and we will give you a steeper discount in exchange for that. So you get up to 72% off of on-demand prices. And with compute savings plan, regardless of any instance family or any operating system or any region you are actually using, you can still get the same discounts that you're signing up with this compute savings plan. And another benefit is you can even decide to, let's say, move from EC2 to Fargate, and you're still covered with the same compute savings plan without having to change anything or any operational overhead. With compute savings plan, you get up to 66% off of on-demand prices for the flexibility you get. The second one is EC2 savings, instant savings plan. This is similar to RIs if you are familiar with reserved instances in the past. With this, you get up to 72% off of on-demand because in this case, you're saying, hey, I am able to commit to using a specific instance family in a specific region. However, you are flexible to launch any instance size within that family and use any availability zone. So the third one, which is of interest today, which is spot instances. So what are spot instances? These spot instances give you up to 90% off of on-demand prices. They are suitable for fault-tolerant, stateless, and time-insensitive workloads. The spot instances are spare EC2 capacity in our AWS cloud. So it's truly our spare capacity. If you think about it, we have to maintain this spare capacity to deliver the elasticity that you expect from on-demand instances. So when on-demand customers are not using this spare capacity, it's available for spot customers to use it. To give you the 90% discount, the caveat is we terminate the instances with a 2-minute notification. So you need to make sure to run fault-tolerant, time-insensitive, and these workloads on spot instances. Since we're talking about containers and spot today, one thing I have to highlight is containers and spot is a match made in heaven. Why? Because containers are fault-tolerant. Your ECS scheduler will make sure to relaunch the interrupted containers. They're stateless, they can run anywhere. So if you're using containers, definitely you should think about using spot instances. So when you think of spot instances, don't just think about how much savings you're actually getting. Think also in terms of how much more you can do for the same cost. And this is what most customers actually do when they're using spot instances. Western Digital is a hard drive company, and one thing to know about hard drives is you need to run millions of simulations. They just ran a 2.3 million simulation test by using spot cluster of 1 million vCPUs, concurrent vCPUs, in a single region. So most of you may not need 1 million vCPUs. However, the key thing to note here is they're able to achieve this scale by being flexible across different instance types and different availability zones. So the key thing, like I said, is in order to be successful with using spot instances and take advantage of this scale of spot at lower cost, you need to be instance flexible. And again, we are talking about containers and spot. And containers give you that instance flexibility right out of the box for you. Because as you are migrating your apps towards containers, you're probably adopting modern architectures and microservices architecture that is making you less and less attached to the hardware, but more and more thinking in terms of how much vCPU and memory I need for my applications or workloads. So when it comes to the Fargate compute option, we used to have only one purchase option so far, which is similar to EC2 on demand. You just pay for use, and there is no long-term commitment. Again, suitable for when you don't know your capacity needs yet. But what we have seen is customers, as they have been migrating their workloads towards Fargate, they started liking the serverless model where they don't have to manage the infrastructure anymore, and they started bringing more and more workloads that need compute for a longer period of time. And we thought we can offer two new purchase options that will help them migrate more and more workloads to Fargate. So the first one is compute savings plan. Like I said earlier, you sign up for a commitment with 1 or 3 years, and you get up to 50% off of standard Fargate pricing. Suitable for steady state workloads, any app that needs a baseline compute that runs for a longer period of time, you can use compute savings plan. Third is Fargate Spot that we just launched it, reInvent. It gives you up to 70% off of standard Fargate pricing. The concept is exactly similar to EC2 Spot instances. Your tasks may be reclaimed with a 2-minute notification, better suitable for fault-tolerant, time-insensitive workloads. So now Fargate has 3 different purchase options: on-demand, compute savings plan, and Spot. There is no other better time to use Fargate but now. And Nick is also going to talk about how you can use ECS with the new features that we just launched in order to mix these different purchase options to meet your workload needs. For example, if you have a retail app that needs baseline of compute, you can cover that with compute savings plan. But if you have some traffic that can be spiky during maybe a Black Friday, you can use Fargate Spot for that. So a quick comparison of EC2 Spot with Fargate Spot. Both are interruptible services with pricing that varies over a period of time that's subject to long-term trends in supply and demand. EC2 Spot runs on spare EC2 capacity. Fargate Spot runs on spare compute capacity in AWS Cloud. With EC2 Spot, you get up to 90% off of on-demand prices. With Fargate Spot, you get up to 70% off of standard Fargate price. With EC2 Spot, your instances can be reclaimed with a 2-minute notification. There are several tools that we are already built into ECS, and also like the most recent node termination handler plugin that we built for Kubernetes. All these help you to manage interruptions in a way that will reduce your service interruptions. So for example, ECS puts the instance that is receiving the termination notification in a draining state, so that the future work won't be routed towards it, and your tasks will be rescheduled elsewhere. And you can also customize the interruption handling by listening to the CloudWatch metrics if you have any other additional cleanup work that you want to do on your own. With Fargate, you receive the same 2-minute notification, but we are sending it in the familiar SIG-term event. So if you're already handling it, you don't have to do any extra work in order to take advantage of Fargate Spot. With EC2 Spot, because you actually manage infrastructure on your own, we suggest best practices like I mentioned earlier, which is instance flexibility. And especially if you're using Autoscaling group to provision instances, we suggest you use mixed instance policies with capacity optimized allocation strategy. This will make sure you take advantage of Spot scale at lower costs. With Fargate Spot, you don't have to do anything because it's serverless and fully managed by us. So the key thing here is identify workloads like batch-style jobs, big data, CI/CD, web services, any of the fault-tolerant workloads. You can take advantage of Fargate Spot because you don't have to do anything. It's fully managed by us, and you can get up to 70% off of standard Fargate pricing. With this, I hand it over to Nick.
Thank you, Deepthi. So now I'm going to spend some time diving into, some ways that you can think about compute cost and performance and how to manage the trade-off between compute cost and performance, and how Spot, especially in the context of running containers, can help you to optimize that trade-off and to get the most bang for your buck. So when we talk about compute cost, I'm going to use a fairly simple framework, but it is one that I find very useful in thinking about this, and I hope you find it useful as well. So the total compute cost, the factors that go into the compute number that shows up on your bill, is really a function of three things. One of those is the number of compute units that you're using, where a compute unit is an instance or a Fargate task. How many of those am I using? It makes sense, right? How long do you use them for? Because you pay per second or per hour, depending on the type of compute unit. And then how much does each unit cost? So pretty simple framework for thinking about total compute cost. Just want to emphasize, when I use that somewhat abstract term compute unit, I mean either an instance, if you're running on EC2, or a Fargate task or pod if you're running Fargate, because that's what you pay for. And that's a big difference between running containers on EC2 and running containers on Fargate, is that when you run containers on EC2, you are paying for those EC2 instances no matter what is running on them. You can run a bunch of containers, you can run no containers, you're still paying for those EC2 instances as long as they're up and running. With Fargate, if you're not running any containers, you're not paying any Fargate costs. You only pay for the containers when they're actually running. That's a big difference between those two. Okay, compute performance. Again, I want to present a simplified framework for the purposes of thinking about the trade-off between cost and performance, a simplified framework for thinking about compute performance. A lot of times when people talk about compute performance, they have some business metric in mind, like how many transactions per second can my website process? How many batch jobs per hour or ETL jobs per hour can my system process? And for those types of performance metrics, you can think of compute performance as having two factors. One is a familiar one, the number of compute units, right? Like if I double the number of instances that's backing my website, then generally speaking, I can double the number of requests per second that my website can process. It doesn't always work exactly that way, but it is at a high level, that's how you can think about it. And likewise, the performance that I get depends on how well each of those individual compute units performs. And again, this might seem kind of obvious, but this is just a really useful, simple framework to think about this. So how well, if I'm running a website that's processing requests, how well that website performs, it's going to be different depending on the instance types that you pick or the number of eCPUs that you put into your Fargate tasks. So when you talk about trading off cost and performance, usually what people are doing in the context of a business is they want to minimize cost while meeting performance goals, as opposed to keeping your cost fixed and trying to maximize your performance. In a business, it's usually the case that there's something that you got to do if your business is going to succeed, right? Like if I'm selling stuff online, if my website isn't up and can't take orders, my business is not doing well. So I have to meet my performance goals, and when I do that, I want to do it at the lowest cost that I can. There's certainly other contexts in which you flip it around and you say, well, I've got a budget to spend, and for that budget, I want to get the most performance that I can get. It's a very similar discussion regardless of which way you choose to look at it, but for the purposes of today, I'm going to focus on minimizing cost while meeting performance goals. So there are actually only 4 different factors that we've seen here that feed into performance and cost. And I think of those as being 2 different groups. There's the cost per compute unit and the performance per compute unit. And then there's the number of compute units and the length of time that you use them. These 4 factors drive both performance and cost. So if your goal is to minimize cost while meeting performance goals, then you really have 2 different activities that you need to do. The first activity is to pick the compute units. To pick the compute units so that you're getting the best price to performance for your workload. So if you're doing high performance scientific computing, there may be certain motherboards and chipsets that perform best on the high performance computing workload that you have, and you're going to pick instance types that give you the best bang for the buck. If you're doing crypto workloads, you might want to pick one of the new Graviton-based instances that perform really, really well on crypto workloads. They're going to give you the best bang for the buck for that type of workload. That's that first activity. There's a whole art and science just to that, which isn't really the focus here today. One of the biggest factors today, for the purposes of this discussion, in that first set of activities is the purchase type. Because if I look at an on-demand instance, C5 16-inch large and a C5 16-inch large that's a spot instance, an on-demand and a spot instance, the performance is exactly the same. There's no difference between a spot instance and an on-demand instance in terms of how it performs, with the exception of the fact that you might lose the spot instance and have it be reclaimed. So performance-wise, you can get a lot more performance per dollar out of a spot instance than an on-demand instance. And if your workload can tolerate not always having that instance available, then that's a really easy choice to make to maximize, to optimize your price to performance workload per compute unit. The second activity is going to be the one that I'm going to focus more on today, which is running the right number of compute units for as long as you need them. That's autoscaling. That's what autoscaling is, right? When you're autoscaling, whether that's autoscaling instances or autoscaling pods or tasks, what you're trying to do is make sure that you have enough to meet your performance goal. If you weren't trying to minimize cost, you wouldn't need to bother with autoscaling. Just run a crap load of instances and you'll be fine, right? You'll have a big bill, but you'll be able to meet your performance goal. But if you want to minimize cost, then you need to do autoscaling, because then you're going to try to make the number of compute units fit the workload that you have. Okay, so I said I'm going to talk more about the second activity, but I do want to spend a little bit more time talking about the first one, which is maximizing that price to performance, or I really should say minimizing the price to performance. You want to pay as little as possible per compute performance unit. So if you're running containers on EC2, there's kind of multiple steps here that you have to think about. When you're running containers on EC2, whether you're using EKS or ECS, you're going to pick vCPU and memory for your containers. You don't always pick the vCPU, but you do have to pick the memory. So you need to decide how big do I need to make my tasks, my pods, to actually fit the containerized workload that I'm running. And then you need to make those fit on the instances that you're selecting, right? Not all instances can run all containers. The biggest knob that you have to turn there, again, is that purchase type. I can really change the equation if I run spot instead of on demand. With Fargate, it's a lot simpler. All I have to do is pick this CPU and memory and choose a purchase type. I don't have to pick an instance because I'm only paying for the Fargate containers that are running. So these are just some of the things to think about when you're picking your compute units to how to get the best price to performance ratio. There is an easy short circuit that you can do in this process, which is certain workloads should just run 100% on spot. There's no reason not to for certain types of workloads. Other workloads might not be as good of a fit to run 100% on spot. So what's good for 100% on spot is anything where you would be okay temporarily not having some compute capacity. So think about an ETL processing system where you're extracting data, transforming it, loading it into another. If you don't have a real tight deadline for that, run it all on spot. If you lose the capacity, it'll take you longer to finish the work, but you'll save up to 90% on the cost to do that work. Same thing with batch processing, right? If you're doing a bunch of image or video transcoding or something, and yes, you need it to finish eventually, but you just want to save a lot of money, run it all on spot. There's no reason not to. Dev and test is another one. You might want your development environment to look just like the production environment, but unlike the production environment, it doesn't have to be up all the time, so run it on spot. Other workloads, like again, I'll just take the website that's selling stuff. If I have a business, I'm selling stuff online, and I run my website 100% on spot, you can do that, but you just need to be aware that you can, in principle, lose all of your compute capacity, and now your website's not available. A little preview of what's coming later, one of the things that you can do with Spot is run some of your workload on Spot, not all of it. So that's actually kind of where we're headed here today. So let's dive into how we're going to do that. So I'm going to talk now about the second set of activities, which is the auto-scaling piece. So with auto-scaling, what you're trying to do is run the right number of compute units for as long as needed, only as long as needed. And if you're running EC2 instances, there's really two different things that you have to think about, because what you control directly when you're running containers on EC2 instances is you're running tasks and pods and they're running on EC2 instances. Your compute units are the tasks or the pods for performance purposes, but what you're paying for is the instances. With Fargate, the two are one and the same. Your compute units that you're getting your performance out of and the compute units that you're paying for are the same thing. That's it might seem like a simple distinction, but it's actually a big deal, because it means that I don't have to think about cluster utilization when I'm using Fargate. I don't have to think about bin packing. There's no such thing. We're doing it for you. You're just paying for the Fargate tasks or pods that you're running. So when you're auto-scaling and you're running on EC2, you're going to be auto-scaling two different things simultaneously. You're auto-scaling the tasks or the pods that you're running, and then you're also auto-scaling the instances that are running them. You need to make sure those two things work well together. If they don't work well together, then what can happen is you're either running your tasks and your pods and you have enough to meet your performance goal and you have too many instances and you're paying too much, or you don't have enough instances and you don't have enough space to run the tasks and pods that you need. So you really need those two things to work well together. With Fargate, again, no such issues. You just focus on running the right number of tasks or pods. So how do you do that on EC2? If you're running on ECS, you use what's called ECS service auto scaling. So you can configure a scaling policy on your ECS service, and you can have more than one scaling policy on the same service, and that will use a metric in CloudWatch to scale up and down the number of tasks that are in your service. So you can do things like say, I'm going to scale based on CPU utilization, and I have a CloudWatch metric that ECS publishes for me, which is the average CPU utilization of each task in the service. And then you can say, for example, I want that to be 50%. And so as the work that your service is doing changes, and it has more work to do or less work to do, that CPU utilization metric will go up and down. And then the service autoscaler will see those changes, and it will add or remove tasks to try to get the metric to go back to 50%. KS, or Kubernetes, there's the horizontal pod autoscaler, which works very similarly. You can target a specific CPU utilization and have it scale in and out to try to maintain that CPU utilization. And then, of course, you need to actually make sure that your cluster scales as well. So in ECS, we just launched 2 days ago a much improved cluster autoscaler. And Kubernetes has the Kubernetes cluster autoscaler, which works similarly. So on both ECS and EKS, if you set up cluster autoscaling and you configure it to like minimize the extra instances that are in your cluster, then the thing that really is driving your number of instances is the number of tasks or pods that you're running. Like, what I mean is that the service or the tasks and pods, that's where your compute performance comes from, and that's also what drives your compute cost, right? Like, if I double the number of tasks that I'm running, then cluster autoscaling, if it's configured properly, will double the number of instances that I need. And if I cut the number of tasks in half, then generally I'm going to cut the number of instances that I need in half. So the thing that drives cost and performance on ECS and EKS when I'm running on EC2 actually is just the number of tasks and pods. Even though there are 2 layers in this auto-scaling cake, the one that is controlling it all, assuming you're using cluster auto-scaling, is the service task or pod scaling. That's the thing that's driving cost and performance. On Fargate, of course, it's kind of obvious, but that's exactly what's driving cost and performance directly because you pay for the tasks or pods, and that's where you get your performance also. Okay, so when we look at this total compute cost, the thing that drives the cost, whether I'm using EC2 or Fargate, is really the number of tasks or pods that I'm running. Even though I am running on instances, in the case EC2 case, it's really the number of tasks or pods that's driving my cost. And then the main factor, assuming that I've chosen my instance types to fit my workload, the main factor that controls the cost per unit is the purchase type. And for the purposes of today, we're going to focus on, on-demand versus spot. So now that we've established the fact that the thing that drives cost and performance is the number of tasks or pods, let's look at a specific example of a service that is being auto-scaled, whether that's ECS service auto-scaling or Kubernetes horizontal pod autoscaler. So typically you're going to use a load metric, and in a steady state scenario, your autoscaler is going to keep the number of tasks or pods constant. So if you've done a good job configuring your autoscaler, then you've got enough tasks or pods to serve the work that needs to be done in that steady state scenario. And then what happens is when that metric that you're using to control the scaling increases because you have a sudden increase in load, by definition, if I'm scaling based on metrics, the scaling happens after the metric increased. And so I have a gap. I have a gap where if in the steady state those 6 tasks was just enough to get the work done, then during that performance increase, I don't have enough. I don't have enough tasks. Now this is better when you're running containers than it is when you're running instances because containers generally can start up faster than instances can. So the performance gap that I have when I run on Fargate or even when I run ECS on EC2 or EKS on EC2 is generally going to be shorter than if I was just running VMs and I'm auto-scaling VMs, but it's still there. I still have a gap there. So what most people do to solve this problem is they over-provision. And over-provisioning, I want to be like super pedantic on the definition of over-provisioning here. Over-provisioning means provisioning more resources than is needed to do the work most of the time, right? If it's not more resources than is needed to do the work most of the time, then it's not over-provisioning. It's just running the right number of workers to do the work. So in this scenario, in that first half of the graph there, I only needed 6 to do the work, but I'm running 9. And so I'm paying more most of the time, but I don't have any performance gaps. So that's good. I'm meeting, remember we said that as a business, generally you're trying to meet your performance goal while minimizing cost. So if I have to make the trade-off here between saying, well, I could run 6 most of the time and lower my cost, but then there's going to be periods of time where I'm not meeting my performance goal, most businesses will say, well, we need to run 9. We can't run 6, we got to run 9. We'll bite the bullet, we'll pay that extra cost because we cannot afford to have this performance gap. Right, so you're gonna make that trade-off between cost and performance. Generally, you're gonna pick performance over cost and bite the bullet on cost. This is where a spot comes in. What you really would like to be able to do in this scenario is not have to choose between 100% on demand or 100% spot and actually split and say, okay, I know that most of the time in that steady state on the left, I only need 6. I do need those 6. I need the 6 to be there, so I'm going to run those on demand. And then the 3 additional ones, most of the time I don't need them. They're there in case I have an unexpected spike in demand to absorb the additional work while I'm waiting for scaling to kick in. So I'm okay running those on spot because while in theory it's true that you could lose your spot capacity, the impact on your business just from a risk standpoint is much lower in this if you're able to do this. And the reason is that, and I'll use a little probability here, generally speaking in probability, if you have one thing that is unusual and another thing that is unusual, and then you say, what is the probability of both of those things happening at the same time? That's even more unusual, right? And so here, if I am concerned about losing my spot capacity, it's only an impact on my business if it happens at the exact moment that I have an unexpected spike in demand. And by definition, those unexpected spikes in demand are not that common, because if they were, then it's part of your base workload and it's not over-provisioning. So an unexpected spike in demand doesn't happen all that often. You also don't lose spot capacity all that often. You take those 2 unusual events, and for both of them to happen at the same time is even more unusual. So you really can here, as Deepthi said at the beginning, you can actually do a better job of meeting your performance goals while saving money if you're able to split your workload across on-demand and spot. And we call this over-provisioning on spot. So let's think about the cost implications here. Just suppose for the sake of argument that those tasks effectively cost, if we're running on Fargate, let's say that each task is $1 an hour. So I'm paying $6 an hour for the on-demand tasks. And then I run 3 spot tasks. On Fargate, those can be up to 70% off. So instead of $1 an hour, they're 30 cents an hour. So instead of paying $6 an hour, I can pay $6.90 an hour, a little bit more, but I get 50% more compute capacity. For services like this one, for like a replicated web service, that's how you should think about Spot. I get a big performance boost for a little bit more money. I'm not trying to replace my existing capacity that I know I have to have with Spot. I'm not trying to take the 6 that I need and replace those with Spot. It's not about saving money on that. It's about saving money on the over-provisioning that I know I also have to do. So how would you actually do this? How would you over-provision with Spot? Well, there's one tool that you've actually had in the toolbox for a while that not everyone is aware of, which is that when you configure an EC2 Auto Scaling group, you can actually define a split on purchase type in the Auto Scaling group configuration. So you can define what percentage of the instances do you want to be on-demand instances and what percentage of the instances do you want to be spot instances. And then the auto-scaling group, as it scales up and it scales down, it will ensure that that split is met. So in this case, I've showed you a little screenshot that's directly from the ASG console where you can define those percentages. So if I want to over-provision by 50% and I want to have the extra 50% be spot instances, then this is how I would do it. I'd have 66% on demand and 33 or 34% spot instances. There is a big caveat with this approach, though. It's really only going to work for single tenant clusters. Single tenant meaning I only have like one workload that I run in that cluster. And here's the reason why. I don't have any control in the ECS scheduler or in the Kubernetes scheduler for defining inside of a single auto-scaling group that I want some proportion of the tasks to run on these instances and a different proportion to run on these other instances within a single auto-scaling group. So if I'm only running one service, this is fine because I'm basically my tasks are going to run on all the instances, and assuming I have a roughly equal number of tasks on each instance, then my distribution of tasks or pods across purchase type will match the distribution of instances. But if I run two services in this cluster, there's no guarantee that one of them doesn't end up on all the on-demand instances and the other doesn't end up on all the spot instances. And now I'm unintentionally putting the service that ends up on the spot instances at risk of a loss of availability. So this works, but really only for single tenant clusters. So we've seen requests for this type of thing for a while, which is why the Autoscaling team launched this feature in ASG. And we see containers customers wanting to do the same thing. So what we've done in ECS is we've actually launched a feature this week that can do exactly this. The idea is if you have multiple auto-scaling groups in a single cluster, you can use this new concept in ECS called a capacity provider. A capacity provider is an ECS resource type, a new ECS resource type that encapsulates an auto-scaling group. And then when you run tasks and services, you can target those capacity providers, and you can define weights for the capacity providers. And I'll do a demo where I show how this works. If you want to see more about this, CON312, there was only one of those, happened yesterday, but 325 is more of a deep dive on capacity providers happening later this afternoon. I'm doing it with one of our senior engineers, so please come to that if you can, or if you've already seen it, that's great. So here's how you actually use capacity providers to over-provision on spot. If you have an ECS service running and it's got 6 tasks, a desired count of 6, or it can be whatever, but I'm just using 6 as an example. When you run that service, you can use what's called a capacity provider strategy for the service, which defines how it should use the capacity providers in the cluster. So if you configure one auto-scaling group to be all on-demand instances, and the other auto-scaling group to be all spot instances, now you have the ability to take that one service and split it across those 2 auto-scaling groups. And the service can control through the weight how many tasks run on each. So for example, if I say that capacity provider 1 has weight 2 and capacity provider 2 has weight 1, and I have 6 total tasks, then I get 4 running on the first capacity provider and 2 running on the second one. This is exactly the scenario that I just described, where I have 50%, I have an on-demand like base capacity of 4 and then 50% more running on spot. And then if I change that desired count, the ECS service scheduler will respect the weights and will make sure that the counts change appropriately on each capacity provider. And the cluster autoscaler, which is really an ASG autoscaler, will make sure that the instances scale in and out as needed on the different ASGs to meet that demand. Not only that, but this is multi-tenant. So I can have multiple services using the same capacity providers, and those services can have different weights. So as a business, I may have decided that service A needs to over-provision by 50%, so that's why I have a 2-to-1 weights. And service B needs to over-provision by 100%, so I have 1-to-1 weights. I can run both of those in the same cluster on the same ASGs, and the ECS service scheduler will ensure that those weights are respected, and then the cluster autoscaler will make sure that the ASGs have enough instances to run all of the tasks from both services. And that as the services scale in and out independently, the ASGs are going to scale in and out to meet the demand from all of the services. So I get multi-tenant services in a cluster, all over provisioning in the way that they need to, and it all just works. This also works with Fargate and Fargate Spot. Didn't put it on the slide, but Fargate and Fargate Spot are also capacity providers in ECS. You don't have to create them. You can just use them, and you can do the exact same thing here. So on the slide where it says ASG1 and ASG2, you could replace ASG1 with Fargate and ASG2 with Fargate Spot, and otherwise works exactly the same. You can have multiple services in the same cluster with different weights using Fargate and Fargate Spot, and it just works. I will take questions at the end. Okay, so I'm going to do a demo. I think I gotta bring my laptop back up. Here we go. Just give me a moment while I get signed in here. Okay. Okay, so I have a cluster here. This is in the ECS console. And in this cluster, I have some capacity providers. I have Fargate and Fargate Spot. Those are the first two. And then I have an on-demand auto-scaling group that I configure to use all on-demand instances. And I have a Spot auto-scaling group that I define to be all Spot instances. Let me I'll start with Fargate. So in the console, in the ECS console right now, if you want to use capacity provider strategies, which is how you control which capacity providers a service will use, you can only do it with this thing called a default capacity provider. In the API and the CLI, you can just do it directly on the service, and we're going to add this capability in the console, but it's not there right now. So I'm going to go create a default provider strategy on the cluster. And so what I'm doing is I'm setting up a default provider strategy, which means that any service that runs in this cluster is going to use this set of weights and providers. That's pretty convenient, actually, because now people using this cluster don't have to do anything. They just run services, and it works. Okay, so I've got my provider strategy set up. Now I'm going to go create a service. Needs to be compatible with Fargate because I'm running a Fargate service. A simple little web server here that I'm going to run on Fargate. I'm just going to do 3 tasks because that'll demonstrate the weights. I should end up with 2 on Fargate and 1 on Fargate Spot. I could use a load balancer and service discovery and all that stuff, but for the purposes of this demo, we don't need that, so I'm just going to keep it simple. Because I do have a network interface, I have to define subnets and security groups. We won't be using those. Okay, create my service. Go look at my tasks. And I see that I have tasks in provisioning, which means that the Fargate subsystem is starting them up. They're going to pending. And then they'll go to running shortly. And while they're doing that, I'm going to click on these individual tasks. So let's look at this one. It says the capacity provider is Fargate. And this one is Fargate Spot. And the third one is running on Fargate. So I have a single service that I split across Fargate and Fargate Spot. I only ran 3 tasks, but if I ran 100, it'd do the same thing. I would end up with 66 or 67, depending on rounding, on Fargate, and 33 or 34 on Fargate Spot. Now let's do the same thing, but let's do it with running on EC2. So I'm going to go update my default provider strategy to use the on-demand and spot ASGs. And I'm going to create another service. And notice I can do all this in the same cluster, right? I don't have to have a different cluster for Fargate. I have a very simple service called Sleeper that all it does is sleep forever. Doesn't really matter for the purposes of this demo if it's doing any real work or not. Let's run, say, 60 tasks. And we'll go through here. And I'm not going to use a load balancer. Okay. So in this case, it's similar to Fargate, and then I just ran some tasks even though I don't actually have any instances yet. There are no instances in this cluster, and yet I ran a service that's supposed to run on EC2. So how's that going to work? Well, the tasks go into a provisioning state, which means they're waiting for capacity. Meanwhile, because I have these 2 capacity providers configured to do managed scaling in ECS, autoscaling, what happens is whenever you have an autoscaling group in ECS that is part of a capacity provider and you run tasks on that capacity provider and there isn't enough capacity, like there's no instances or there are but they can't run your tasks, we're publishing a metric to CloudWatch that indicates how full that ASG is, and the metric can go above 100%. So if I don't have enough capacity to run the tasks, the metric goes above 100%. And when it does that, and it just happened here for both of those ASGs, then there are some CloudWatch alarms, and this is all set up for you. You don't have to do anything in ECS to enable this other than opt in to manage scaling in your capacity provider. And actually, you can see one of the alarms already fired. There's a CloudWatch alarm that then fires, which then triggers the EC2 Auto Scaling groups to scale out. So let's go look at our Auto Scaling groups. Yeah, actually, I can see I already have 2 instances in both. So I've started to scale out. They take a little bit of time to join the cluster. It's not instantaneous because the instance startup process has to happen. And then when that's done, the ECS agent has to start up and phone home and register with the cluster. So while that's happening, let me talk a little bit more about how you can use this. So capacity providers are backwards compatible in the sense that I can use capacity providers and I can also just use launch type with EC2 and Fargate in the same cluster. So you can start to adopt capacity providers without having to switch everything over in your cluster all at once. You can change capacity provider weights. So if you are, say, using 2-to-1 and you decide that you want to use 1-to-1, you can change that, update the service, and it'll go through a deployment and it'll change the weights. You can also use this for things like migrating from one AMI to another, like you have your old ASG with the old AMI and the new ASG with the new AMI. You can take a service and switch it over by using capacity provider strategy. So there's tons of things you can do besides over-provisioning on spot. Let's take a look and see if my instances have come up yet. Yes, okay. And they're running tasks already too. In fact, you can see, so I did this on purpose because the console doesn't yet show which instance is in which capacity provider. So US East 1A availability zone is where all of my on-demand instances are. and US East 1B is where all my spot instances are. And remember I had 2-to-1 ratio. So how many on-demand tasks do I have? I have 40, and I have 20 spot. So it's exactly what I showed you. The service scheduler is portioning out the tasks to different ASGs, and then the ASGs are scaling up to meet the demand. I could run another service on the same ASGs with a different split, and it would still work, and the ASGs would scale automatically. Unfortunately, today, this capability to do that type of split is not available in Kubernetes. It's going to require a change to the Kubernetes scheduler to support this. 1.16 comes close. It has this thing called a spread topology, but it doesn't support different like weights or counts on the different spreads. However, because they've already introduced some of the capability that is on the road towards this, I think that you'll see, my guess is that you will see that change in Kubernetes, and you'll have the ability to do the same or very similar things in Kubernetes at some point. So that's my demo and the presentation. We still have some minutes here for questions. Yes, sir.
If you were to go back and edit the Fargate cluster and add more tasks, like up to like 5 tasks, how would it split it, and do you have to change the configuration back to be the way it was for Fargate before you modify it since you changed it?
Yeah, so the question is, if I wanted to go change the Fargate service, and there's 2 different changes we could talk about here. One is updating the desired count of the Fargate service, and for that I just go update the service and change the desired count. It would split.
But it's not modular.
Yeah, so it's plus or minus 1 based on rounding. So if you have 5 and you do 2-to-1, I don't remember off the top of my head how it works out, but there's an algorithm where it gets as close as it can to the split that you've defined. Yes, sir.
So I'd like to define a service that runs a base number of tasks on Fargate, and then say a minimum of 2, and all tasks above that would run on the spot. So
Yeah.
I do that, and I go to scale, and there is no spot capacity. Will it fall back to on-demand?
So the question is, you want to have a service that defines a base capacity of 2 on regular Fargate and then everything else on Fargate spot. Right now, you can't do that. We will be adding that capability very, very soon to have the base parameter, and there actually is a base parameter you see in the console, but for services, it needs to be 0 right now. Very soon, we will be adding that so that it could be a non-zero base. So for the purposes of discussion, let's just say that we've already launched the base capacity feature. What would happen if Fargate spot, you lose your Fargate spot capacity? Then you don't have you don't have the desired count for your service. We don't have an automated fallback capability because that's just not how spot works. You really want to think about it as extra capacity that if it goes away, you can still meet your business goals. That being said, you can update the capacity provider strategy on a service, so you can change it after it's running to be whatever you would like it to be. Yes, sir.
Okay, so what's the pros and cons between the usage of like the first option you mentioned, each instance type in a single auto-scaling group with like only let's say C4 XLR, C4 2 XLR in the same auto-scaling group, while 2 auto-scaling group, each one has one single instance type, say one auto-scaling group of one has just C4 XLR, then auto-scaling group 2 has C4 2 XLR. I know that the option 1 do this thing is that if the capacity for C4 XLR runs out of the capacity availability, they're gonna go to the second instance type. But will that happen on the second option 2 as the one that is available for other benefits of the
Excuse me. So the question is, if you want to use more than one instance type, you kind of have 2 different ways that you could do it. One is in a single auto-scaling group, you do have the ability to have multiple instance types. With capacity providers, you could also have multiple auto-scaling groups, each with a single instance type. And this is a multi-part answer here. First of all, if you're using Spot with EC2, as Deepthi was saying, it's highly recommended that you actually do use multiple instance types in a single auto-scaling group, because you will reduce the likelihood of not getting your capacity if you do that. So you do want to diversify instance types with Spot. But in an auto-scaling group, you can, even with an on-demand auto-scaling group, have multiple instance types. The ECS cluster auto-scaling feature and the Kubernetes cluster autoscaler has this same caveat to how it works. It's going to work a lot better if your instances all have similar capacity. So you can use the Kubernetes autoscaler, cluster autoscaler, or the ECS cluster autoscaler with, you know, a T2 micro and a C5 24x large in the same autoscaling group, and it'll work, but your scaling won't be very efficient. You'll end up over or under scaling quite a bit. But it will still work in the sense that you will scale out when you need to. It just might take longer, or you might end up getting too many instances when you do that. So our recommendation with ECS would be do your best when you pick multiple instance types to have them be similar in capacity in the resource dimensions that matter. So if your workload is primarily CPU constrained, then try to pick instances that have similar amount of eCPUs, or similar amount of memory if it's memory constrained. But ECS cluster autoscaling and the horizontal pod autoscaler will still work even if you have multiple instance types. Does that answer your question? I think we're out of time now, so we can do some one-on-one questions up front.